Next up, we have a quotient rule, and the quotient rule is basically used whenever you have fractions with x's in the numerator and x's in the denominator, and the question says find the derivative. Now, according to the quotient rule, if you look carefully at how the formula is designed, it basically says if you have a numerator divided by a denominator, then the rule basically says find the derivative of the numerator, multiply with the original denominator. Once you're finished, multiply the derivative of the denominator with the original numerator and then subtract. And also, you're going to need a massive denominator that is derived from the old denominator. It's actually the old denominator that was there, but squared instead. So that's basically how the quotient rule is going to work. So to help us out a little bit here, I'm just going to design it similar to how we did with the product rule. I'm going to set up a table on the side, figure out what the parts are, what the derivatives of each thing is, and then multiply and subtract according to the rule. Just be careful that quotient rules are only used when you have x's on the numerator and x's on the denominator. Otherwise, we don't use the quotient rule. We use something else. So in this particular problem, we are going to be using a quotient rule. So let's begin by writing that. So the word quotient just means fraction. So this fraction that we're dealing with has x's on top, x's on the bottom. So what we're going to do is label each one of those. So who's first and who's second. And it's the same setup always. Then who's first prime and who's second prime. Okay, the word prime is just another way of saying derivative. So in this particular problem, the first is going to be the numerator. And this is the way it works for all of the problems where you have fractions. Your first is always the numerator, and your second is going to be the denominator, so the 3x plus 5. Now directly across from them, you're going to put the derivatives. Derivative of 2x minus 1 will be 2. Derivative of 3x plus 5 is going to be 3. And we're going to do something similar to what we did with the product rule. We're going to put an arrow starting with the 1 prime going around as usual, except this time we're going to put a minus instead of a plus. So that's important. It's now a minus, not a plus. And here we go. So the derivative of the question, the 2x minus 1 divided by 3x plus 5, the derivative of that expression is going to be a massive fraction. And on the numerator, we're going to follow the arrow around and put 2 times 3x minus 5 minus 3 times 2x minus 1. So again, the corners get multiplied as usual. The 2 gets multiplied with the 3x plus 5. Those are the opposite corners. And we multiply the corner 3 with the corner of the 2x minus 1. Okay. Now, keep in mind that we need something to go on the bottom, and what goes on the bottom is the old denominator, but this time squared. The old denominator used to be 3x plus 5, so write it down and add an extra square on the outside of it. Now, typically with these problems, we don't FOIL the denominator. We just FOIL the numerator, we combine like terms, but we leave the denominator alone. We don't mess with it. So in other terms, this means that I'm supposed to multiply the 2 with the 3x and 2 with the 5, then the 3 with the 2x, then the 3 with the 1. So negative 3 times negative 1 is going to be positive 3. And I don't mess with the denominator. I just leave it alone. We don't touch it. And finally, combine like terms. In this particular one, 6x minus 6x is going to go away. We end up with 13 divided by 3x plus 5, all to the power of 2. So that's the derivative of the original question. So I think it's pretty straightforward, and I want you to try the next question. So it's the same kind of concept, the same kind of idea. I would like you to try this one out next, and I'll give you the answer in the next video again.